Hello, beautiful people, and welcome. In today's video, we are talking about the Pythagorean theorem, the converse, and the inequality theorem. Let's go ahead and jump right in. Now, you'll notice that the theorems have been pre-written out. So when you are taking notes, go ahead and pause the video so you can write these theorems down. So the first one we have is the Pythagorean theorem. Now, when we hear the Pythagorean theorem, we kind of know what it is. We have this formula memorized that we'll write down in a few moments. So in a right triangle, we have to have a right triangle. The square of the length of the hypotenuse. Now, the hypotenuse, when we originally are taught this in grade school, that's usually called like the hippo, right? The hypotenuse. The hypotenuse is the largest side and it is always across the street from your right angle. So it's opposite your right angle. And since we call it the hungry hippo for hypotenuse, we abbreviate it as hippo. Then we have the legs. Okay, we have the legs of a triangle or the sides. So we have a leg here or a side, and we have a leg here or a side. Doesn't matter which one we have here and here. When we write out the formula, the order can be switched. Now, what cannot be switched is the position of the hypotenuse. Hypotenuse has to be the largest side. So we have three letters, A, B, and C. C is always the hypotenuse. C is always the largest side. The leg A and B can be switched as I previously mentioned. So this can be B, this can be A. That doesn't matter. So we have the formula of A squared, so a leg squared, plus B squared, the other leg squared, equal to C squared, which is your hypotenuse squared. So this is the Pythagorean theorem formula that we use to solve right triangles. Now, we do have what's called a Pythagorean triple. Now, a triple is a set of three positive integers. So three positive numbers, A, B, and C. They cannot be a decimal. They cannot be a fraction. They cannot be negative. And when we have these perfect Pythagorean triples, things just work out. Now, the most common one that we have is our 3, 4, and 5 Pythagorean triple. Now, this one's special because these are consecutive numbers. They are in order 3, 4, 5. And this is going to come up later on in your mathematical journey. Now, another special or common Pythagorean triple is 5, 12, and 13. Another one could be 8, 15, and 17. So why are they called Pythagorean triples? That is because, let's take the first one. That is because 3 squared plus 4 squared is 5 squared. And again, they are positive numbers. They are not decimals, not fractions, and they satisfy the equation a squared plus b squared equals c squared. Let's go ahead and prove that here real quick. We have 3 squared, which is 9, 4 squared, which is 16, and then 25 here, making sure that 9 plus 16 is in fact 25, and indeed it is. And that is why it is called the Pythagorean triple. Now, the same thing works for 5, 12, and 13, 8, 15, and 17. And what's really cool about these, let's actually do one more before we move on. There's another one that is 7, 24, and 25. Now, what's really cool about these is that there are others derived from here. So you can come up with many, many different Pythagorean triples as long as you use these as your base. So how to find others, you take your original numbers and you multiply by a common multiplier. So we can have 3x, 4x, and 5x. We can have 5x, 12x, and 13x. We can have 8x, 15x, and 17x. And we can have 7x, 24x, and 25. x. So for example, let's try to find a different Pythagorean triple. Since we did the 3, 4, 5 Pythagorean triple, I'm going to stay with that. And so let's take our 3x, 4x, and 5x1. So if I choose x to be 2, that means we have a different Pythagorean triple as 3 times 2, 4 times 2, and 5 times 2. That means that we have a Pythagorean triple as 6, 8, and 10. Now again, that can work with the other formulas. For example, this one here can become, if we choose 2 to be our x, so 2 times 5 is 10, 2 times 12 is 24, 2 times 13 is 26. Now it doesn't always have to be 2, we can do 3, so if I plug in 3 here, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15. That also would be a Pythagorean triple. Let's go ahead and do a quick example for the Pythagorean theorem, and we're going to solve for x. Now notice I did not leave myself a lot of space here. We don't need a lot of space to work with the basic Pythagorean theorem where we just have integers, so 7, 14, and x. As you see in the next examples, we will need a little bit more space for those. All right, let's go ahead and set it up. We got a squared plus b squared equals c squared. We know we can use this because we have a right triangle, and we know that across the street from the right triangle is going to be your hypotenuse, your hippo. Now your your hypotenuse, is always your C value. What you choose for your A and B, that doesn't matter. So I can have my A here, I can have my B here, or I can switch these. Now C cannot be switched. C has to be across the street from your hypotenuse. All right, so we got 7 squared plus, you can keep it as b if you'd like, or keep it as x since x is b, and 14 squared. Now you have a choice to make here. You can either solve this, for example, as evaluate 7 squared, evaluate 14 squared. What I actually like to do is I like to keep it. I know I'm going to be subtracting whatever value of 7 squared is. Now I know what that is, but we're going to pretend we don't. And then in our calculator, I type this exactly how I see it. So I see 14 squared minus 7 squared. And I get 147. Okay, we're going to take the square root of 147. And now depending on what your question is asking you, sometimes they will ask you to leave it in exact format. As we're going to see throughout our lessons, that radicals are common here. And you have to read the directions if they want it in a decimal format. Now in this example, it didn't state that it wanted it in a radical exact form or a decimal, so we're just going to do a decimal of about 12.1. All right, let's go ahead and move on. Now this one is asking us to find the missing sides of the right triangle. So we need to find all 3 sides. We have 10. We know this is a right triangle. So that means across the street from the right angle is your hippo, your hypotenuse, and that is your C value. Now again, what you choose for A and B doesn't matter. This can be your B value, this can be your A value, whichever. Since we have a right triangle, we know we're going to be using the Pythagorean theorem, which is our a squared plus b squared equals c squared. Go ahead and set this up. Now this one, notice that we have a binomial, so that's going to be a little bit tricky in making sure that you write this the correct way. So we have a squared. A now needs to be in parentheses because it's not just one thing, it's 2 things. B is just x, and C is 10. Be careful with a binomial. Okay, this is where you need to be careful. It's not x squared plus 4. That's not what we have. When you have a bubble squared, when you have a parentheses or a binomial squared, that means you have that bubble, that binomial, twice. Okay, that's what it means to have a binomial squared. And when you write that out, then you can distribute, FOIL, depending on who your teacher is. If you're with me, you can distribute, or you can choose to do a box method. Now the other ones I will go ahead and simplify 10 squared as 100. Moving forward, you can do a box method here if you want, or you can distribute. I'll choose to do a box method here, and then I'll distribute on the other side so you guys can see both ways. We have x squared, 2x positive, 2x positive, 4. So that means we have x squared plus 4x plus 4. Or you can do it by distributing. So we have x squared plus 2x plus 2x plus 4, like this. I'm going to put this in parentheses just so you guys know that the rest was separate. But again, both of them should be the same. So we have x squared plus 4x plus 4 plus x squared is equal to 100. Go ahead and move everything over to one side. This is a quadratic equation here. So we have 2x squares plus 4x plus 4. I'm going to subtract 100. 2x squared plus 4x, and we got 4 minus 100, and that gives us a negative 96. Now don't forget to set it equal to 0 because we are going to factor to solve. You can choose to use a quadratic formula as well here. That's okay. So I'm going to first remove the GCF, which is 2. I'm going to continue to factor. Again, if you are not solid on factoring, you can do this using the quadratic equation. And if you're choosing that, you don't need to remove the GCF. For your quadratic formula here, you can use this one. But if we're factoring is really important. So what are our factors? We're going to guess and check. We have a trinomial with a leading coefficient of 1. So we have what multiplies to a negative 48, but adds up to a positive 2. And I believe it's 8 times 6 is 48 indeed. So we have 8, that's positive, and negative 6. Now we're going to be using the zero product property, setting each one equal to 0, and solving for x. Now, if you're choosing to set 2 equal to 0 as well, that's fine. Just note that this is a false statement. 2 is not 0, so we exclude it from participating in our answers. So you have x is equal to negative 8. X is equal to positive 6. Okay. Now, if we're looking at these two answers, and we're looking at the triangle, one thing that when we're dealing with these figures, they either exist or they don't. So we either have a triangle or we don't have a triangle. And if we're looking at our x values, notice that one of them is negative. Now, x can be negative depending on what you are given here. What you cannot have is a negative measurement. So if I was to replace x with negative 8, like we have it, that means this side is a non-existent 8. Well, it either exists or you don't have a triangle. So this right here is called an extraneous solution, means it doesn't work. So we're going to exclude negative 8 and only have a positive 6 here. Again, x can be negative. There's nothing wrong with x being negative. The problem is when we plug it back in, it gives us a negative total measurement for this side, and here it still would be a negative measurement. So we can't have the sides of a triangle be negative. That's the issue. All right, let's go ahead and do this one more time. And beautiful people, at any point, if this is going too quickly for you, please pause the video and then make sure you're writing things down. All right, let's go ahead and try this again. We see a right triangle, so across the street from the right triangle is your hippo, your hypotenuse, which means that x plus 8 is equal to your c value. Your a's and b's don't matter, so we can call this a, we can call this b. We have our equation of a squared plus b squared equals c squared. A we have as x, b we have as 20, c we have as x plus 8. You must have parentheses there, that really matters. And then immediately when you see a binomial squared, a bubble squared, go ahead and write it out twice because that's what you actually have. Okay, so we're going to multiply things out. Again, for this one, you can choose to distribute. You can choose to do box method. So we have x squared plus 20 squared, which is 400, is equal to, and I'm going to choose to distribute. So x times x is x squared. X times 8 is 8x. 8 times x is 8x. And 8 times 8 is 64. I'm going to move everything over to one side. So I'm going to choose to move this x squared. I'm also going to choose to move this 400. So we have nothing here. 8 plus 8 is 16. 64 minus 400 is negative 336. Now again, you can choose to factor this, but since it's just a binomial, we have two terms, that nothing is squared. I'm going to continue solving by moving everything over. So I'm going to add 336 to both sides. We have 16x is equal to 336. Divide by 16. And we get 21. Again, got to double check this answer. Plugging it in, 21 plus 8 is not a negative number. Plugging in 21 here, again, not a negative measurement, so 21 works just fine. Now that we learned the Pythagorean theorem, there is a converse of the Pythagorean theorem. Take a moment to pause this and write this down. So the converse of the Pythagorean theorem states that if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. Okay, what does that mean? That means that if a squared plus b squared equals c squared, then the triangle ABC is a right triangle. But wait, didn't we just do that? We had a formula, a squared plus b squared equals c squared. We talked about a right triangle. Now what's the difference? The difference with the converse is you do not know that it is a right triangle. You are trying to prove it is a right triangle. So I'm going to go back into our notes where we have our Pythagorean theorem, just for a quick second. And so Pythagorean theorem says that you have a right triangle. That's given to you. You will see a little box to show that you have a right angle. For the converse, you do not know if it's a right triangle. You are trying to check or prove that it is a right triangle. A little running out of space here, but that's okay. So we need to prove or check for a right triangle. So if this works, then yes, you have a right triangle. If this doesn't work, then no, you don't have a right triangle. All right. Tell whether each triangle is a right triangle. So how do you do this? Step number one, you're going to look for the longest side. Now, sometimes it's obvious, like for example, this one we got 14, 22, and 26. Obviously, 26 is the longest side. And your longest is going to be your C value, always. Now, I'm not calling this the hypotenuse because we do not know if it is across the street from a right angle. All we know is that 26 happens to be the largest number. Now, for something like this, I don't know what the value of 3 times the square root of 34 is. So that's where my calculator is going to help. So we got 3 square root of 34. That gives me 17.49. Okay, so 3 times the square root of 34 happens to be the largest side. So you're going to look for the longest side. You're going to label it C. Once you have C, the other ABs don't really matter, just like with the Pythagorean theorem. So label your other sides. So we can call this A, we can call this B, we can call this A, we can call this B. Again, the other two, that doesn't matter. C is really important. You have to have that in the correct position. Step number 3, check A squared plus B squared equals C squared. So I'm going to do the first one here. So we have, let's call this, what do we want to call this? Example 1, example 2, so I don't get them mixed up. So we have 9 squared plus 15 squared. You don't have to put parentheses. I don't know why I did. Oh, yes, I do. This one, and I will highlight it, needs to be in parentheses. Exactly like this. The 2 needs to be outside the parentheses. Super duper important. Now, 9 and 15, they don't have to be in parentheses. That's fine. But this one does need to be in parentheses. So how do I type this into my calculator? I'm going to type it in exactly how I see it, leaving the equals as my separator. So 9 squared, again, you do not need parentheses here. 15 squared, don't need parentheses there. And you're going to evaluate that at 306. Now we're going to check, right? We don't know if this is equal. We don't know if that's equal, excuse me. Now this one, you must do parentheses. So how do you type this in? Got something on my calculator here. So how do you type this in? We got parentheses, 3 square root of 34. Now don't let that scare you. Don't let the square root scare you. Let the calculator do the thinking for you. All we care right now is, are they equal? So parenthesis, 3 square root. Now when you type in the square root, the parentheses should automatically appear. So at the end, you need a double bubble. You need double parentheses, then press the squared button. Equals. Now this one is 306. So what does that mean? That means that yes, we have a right triangle. Okay, let's do it again. Just separate this out. So we got 22 squared plus 14 squared equals 26 squared. Again, largest side needs to be your C value. Super duper important. Now this one, no square roots here, so we can just type this in. Again, two different parts, 22 squared plus 14 squared equals 680. And we're checking, right, because we don't know, so I'm going to put a little question mark here. 26 squared is 676. So because they are not equal, no, not a right triangle. So notice, yes, it is a right triangle. I went back and put a little box here. No, it's not a right triangle. I'm not putting a box there. This is not the hypotenuse. It's just the largest side. Right, moving forward, we got one more, and that is called the Pythagorean Inequalities Theorem. Let's go back actually for a quick second. So looking at this example, so we have no, it's not a right triangle. Okay, well, it's not a right triangle, then what kind of triangle is it? We have three choices. We have an acute triangle, which is small and pretty. We have a right triangle, which is 90 degrees, and then we have an obtuse triangle, right? It's the largest triangle with an angle that's larger than 90 degrees. So what kind of triangle is this? Well, using the Pythagorean inequalities theorem, we can determine what kind of triangle we have. Do we have do we have an obtuse triangle or do we have an acute triangle, acute and small triangle? So the Pythagorean inequalities theorem, go ahead and pause this to write this down. But what it says is, for any triangle ABC, where C is the length of the longest side, the following statements are true. If the largest side is smaller, then we have an acute triangle. If the largest side is larger, then we have an obtuse. Now again, think about what it is. We have the a squared plus b squared c squared, right? I'm not going to say equals because we're not talking about right triangles right now. An acute triangle is small and pretty, so the largest side is going to be smaller in the formula. If the obtuse triangle is what we have, then it's larger. It's a larger angle, larger than 90 degrees. So the hypotenuse, oh, I said hypotenuse, not a hypotenuse, the largest side, not a right angle, not a right triangle, not a hypotenuse, okay? So for an obtuse, it's larger, so it's larger than 90 degrees, so your largest side will also be larger. Okay, how do we classify triangles? So we're going to have three formulas. So if we have c squared, and I'm going to kind of change up these formulas just a little bit because we're so used to doing a squared plus b squared equals c squared. So a squared plus b squared, a squared plus b squared, a squared plus b squared. So that part won't change. What will change is the symbols. So with an equals, we know a squared plus b squared equals c squared. That is going to be your right triangle. Now an acute triangle, like I said before, is small and pretty. So that means your c squared is going to be smaller than your a squared plus b squared. So that's going to be an acute triangle. And then here, if your c squared is larger, then we have an obtuse triangle. Okay, let's go ahead and do quick example one of each, and then we'll wrap up this video. Thank you for staying as long as you did. All right, for an acute triangle, let's actually start with the right triangle since we already did it. So we're going to check which type of triangle it is. Let's do, I don't know, 24, 45, and 51. Okay, which one's the largest side? Largest side is 51. So we have 24 squared plus 45 squared is maybe equal to 51 squared. We're checking, right? So we got 24 squared plus 45 squared, and I'm typing this in just like that. That gives me, ooh, large number, 2,601. 51 squared is 2,601. Therefore, yes, we have a right triangle. Okay, let's go ahead and try this one out. So let's do 3, 4, and 8. And I'm hesitating because I think that's going to be an obtuse triangle. I'm going to go ahead and erase that. Let's do it off to the side because I don't want to put it under the acute triangle if it's not acute. So I'm going to erase that. I apologize for that. Hesitated there for a second. Let's do that 3, 4, 8 triangle, but off on a separate sheet of paper and then write it in the correct section here. So we have 3, 4, and 8. Obviously, 8 is our largest side. So we have 3 squared plus 4 squared. And I'm going to put a little box here. We don't know what the symbol is. Is it bigger? Is it less than? We just don't know. So we have 3 squared plus 4 squared. That is 25. 8 squared is 64. So 25 is smaller, 64 is larger. That means that the largest side is larger when you square it than the addition or the sum of the other two sides. So if we go back here, that means that yes, my assumption was right, that we did have an obtuse. So let's go and rewrite that example here real quick. 3, 4, 8, and we have a, what did we have? 3 squared plus 4 squared. Again, we're not writing equals. We're going to write a little box here. You can put a little circle there. You can put a little question mark there. So we had 25 is less than 64. Again, this was larger. So we had an obtuse triangle. We have one more example, and that's going to be for an acute triangle. Pulling up an example right here. Okay. And again, let's do that off to the side, double checking, and then we'll go back in. All right, so let's go ahead and check. Which one do we want to do? Let's do this one. We have a 5, and a 7. Again, it doesn't matter that you have repeated numbers. You're just looking for the largest side. So we have 5 squared plus 5 squared. Again, I'm not writing in equals. I'm just writing a little box. You can put a little question mark here if you want. 7 squared. 5 squared plus 5 squared is 50. And then 7 squared is 49. So 49 is smaller than 50. So that means if we go back to our notes here, smaller means acute. So we have, I'm just going to write this down really quick, 5, 5, 7. We had 5 squared plus 5 squared. Little box here, 7 squared. You can put a little question mark in there. We had 50 is bigger than 49. So that means 49 is smaller. And that means you had an acute triangle. All right, beautiful people, that is it for the video. If you are in my class, you have your homework assignment that is posted to Google Classroom. Enjoy the rest of your day, and I'll see you in our next video. Bye.